This is Balancing Chemical Equations Algebraically. Again, with Margaret. I'm working back through a problem from part 2 and using a different substitution to show that this can work. No matter which equation you start to work with first, it's your choice. We have oxygen plus cesium produces oxygen cesium. And I assign the variables again to each part of the equation, giving me oxygen is 2A equals C, and cesium is B equals 2C. In this case, I'm going to use the value for C, substitute in the second equation, so I get B equals 2 times 2A equals and B equals 2C. So now I have, I'm going to want the 8 first, so I have 4A equals B equals 2C. Take the reciprocal, I get 1/4. And, can someone read that? Well, I can't. That's a B. 1 and 1/2, which gives me, again, I factor out the 4. That's like the least common denominator. Probably most of them, who knows? I'm apparently not the greatest in this terminology for some reason. 1 equals 4 equals 2. And, you don't need that stuff actually. I can just go straight up here. A equals 1, B equals... It's not a great idea to skip steps. I've found that when I've gone back to math, and when I'm tired or whatever, if I skip steps, I'm very likely to make mistakes, where I used to not do that. So it's really good to get in the habit of performing every step, whether or not you think you need it, it'd be faster otherwise. But here we have B is 4 and 2. So I get oxygen is 2 times 1 is 2. Oxygen 2 times 1 is 2. And cesium 4 times 1 is 4, and 2 times 2 is 4 for the cesium, so it balances. What I was trying to say before is that I would keep the denominator and numerator separate if I was programming this to reduce division errors, and maybe try to factor at some point. I don't know whether or not it's necessary, but to avoid those rounding errors,